Hello everyone, my name is Malek and I am here with another presentation. In this video, we will discuss about Helm as a Kubernetes package manager. Let's start with what is Helm. Helm is a tool to help us define, install, and upgrade application running on Kubernetes. So we have to analyze it. If you search on internet, you will see another sentence about it. It is the Kubernetes equivalent of Yum in CentOS or apt in Debian Linux distribution. So let's analyze this one. If you are using Linux and you want to install a package or application on your machine, normally you are using of Yum or apt. Yum it's uses in CentOS or Red Hat based distribution, and apt is based of Debian system. In CentOS machine, for example, you want to install Vim editor. You will go with Yum install Vim, and with click on enter button, it will go and install Vim on your machine. So how it find Vim? If you want to install Docker on your machine, how Yum find this package and install it on your machine? If you check your CentOS machine, you will see this folder in this path. In this folder, if I check the list of files, for example, I will see this repo list. So when Yum want to install an application or package, we'll go and check these repositories. If in these repositories the requested application exists, it will go and install it on your machine. If it couldn't find, it will show you cannot find like that. Let's check in terminal cd etc yum.repo.d ls-latr. You see, at the moment, only these three repos exist on my system. If I open one of them, for example, the first one, you see some URL defined here. And when I search, for example, for docker.ce, it will go and check this URL. You see, no matching packages to list. But if I search for Yum info Vim, the Vim editor, it can install Vim on my computer through this repository or through these repositories. So if I want to install Docker on this machine, at first I have to add a repository that can have Docker inside that repo. Otherwise, cannot install it. Here is the Docker official website, and mention it here. If you want to install Docker on your CentOS machine, you have to set up the repository. Here, this is the command. Let's copy and back to terminal and just enter. If I do ls-latr in yum repos.d folder, you see this repo added here. If I open this repo, you see some URL link here. It will go and download Docker from this URL. So now if I run yum info docker ce, look here, you see it will go and download it from this URL that is located in this repository. So at the moment, if I want to install it, just type yum install docker ce. Look here. So when it wants install docker ce, it will go and install 34 packages. It means Docker is composed of 34 pieces. So with installing all these 34 packages, 34 pieces, then you can use of Docker. If one of them, for any reason, for example, Docker Buildix plugin, Docker Compose plugin, or I don't know, Docker CE, for any reason, didn't install, you cannot use Docker properly. So when it says Helm is the Kubernetes equivalent of yum or apt, now we can sense it. So each application that want to install on Kubernetes, it consists of some objects. It consists of deployments, consists of secrets, consists of services, and so on. Let's go a little deep and understand how with helping Helm we can deploy our application on Kubernetes. Imagine we have this application, a login platform. So I want to deploy it on Kubernetes cluster. So at first I have to build an image from my application and then deploy it on Kubernetes cluster. So the image is ready and I did publish it inside GitLab image registry. For deploy this image as an application on Kubernetes cluster with 3 replica, I need to have a deployment manifest. You see here, this is a deployment manifest with 3 replica. If you have a closer look to this manifest, you will see we need a user and password to access this private registry. So we cannot hardcode username and password in manifest. So what we can do, we need a secret. So we have to deploy a secret manifest inside Kubernetes cluster that allow deployment to have access to GitLab private registry and download image and bring up the requested paths. So after all the paths be in service, for access them through outside the Kubernetes cluster, we need to use service object in Kubernetes cluster. So for deploy all these manifests, we need to run them one by one by kubectl apply -f, the name of the manifest. At first, kubectl apply -f secret, and then kubectl apply -f deployment, and after that kubectl apply -f service manifest. You see, for bring up a very simple application, we need 3 times run this command. If we look to application in big scale, normally we need more objects like persistent volume, like config map, and many other objects. So if we need to change, for example, a label inside of this manifest, it will be like a pain in neck, and we will confuse with many things, and with a small mistake, it will take a long time to take care and troubleshoot the application. So this question comes to our mind. Is there a way to deploy or install our application with all necessary objects on Kubernetes and don't need to apply these components one by one? If for any reason want to change image with new one or change the secret for access to repo, how can do it in easiest way? Here Helm comes to play as Kubernetes package manager. In Helm, instead of using the package, we will use chart. Just keep this word in your mind, and we will go in details in next minutes. With using Helm, we can easily, like this, by a single command, do Helm install, for example, app login. If we want to uninstall it by one command, just type Helm uninstall the name of application. If new image of application released, with Helm upgrade the name of application, we can do upgrade. Also, if any bugs or problem found on new release, it's easy to roll back to the last version. Until now, we learned why Helm called as Kubernetes package manager. So let's go into the next chapter for more details. Now we want to know how we can put all necessary files of login application in a package to use Helm for deploying it on Kubernetes cluster. So after the package be ready, we can push it on a repository to be accessible for all team members. Before going in action and playing with Helm, we have to install it. So how to install Helm? Just in Google search installing Helm and it will show you the link of Helm official website. Just click on it and it will forward you to the Helm official website. Here is Google, click here, and here is the Helm official documents. Just click on Introduction and Quick Start Guide. Here you see prerequisite. One of them is you have to access a Kubernetes cluster, because during the installation, Helm need to have access kubeconfig file. So let's back to terminal and check kubectl get nodes. Yes, it show me there is one node as name control plane, so we have access to Kubernetes cluster. Now we can install Helm. Let's back to documentation. Click on installing Helm. Here there are some ways you can install Helm on your machine. One of them is using binary releases. Another one is using this script. There is a script here, you can use it. And also you can do through package manager for different operating system like Mac OS, Windows, and different distribution of Linux like Ubuntu, Fedora, and so on. So the easiest way is using package manager. Just based on your operating system, select the command and copy paste on your terminal, and it will be installed on your machine. Here I already did on my computer. Here just type Helm version and you see I have already installed on my computer. Okay, let's start with Helm Charts and create a chart for our login application and see how it works. Before that, let's see how we can create a chart. For create a chart, just type Helm create chart name. For example, Helm create, give it a name. For example, I select this name, test-login-app. Just click enter and it will create a folder with the selected chart name. Let's go into terminal, type Helm create test-login-app. Enter. The chart created. So ls, you see here a folder with this name created. If I get a tree of this test application, it will show you there are some file also has been created inside this folder. Let's see what are these file. If I back to my presentation, I added a little info about them. In the first line, you see the chart name that we have selected in create command. Also in chart folder, you see a file with name chart.yaml. This file gives us information and description about chart. Back terminal. Let's see the content of this file. In this file, you see API version. The API version that this file is using to communicate with Kubernetes cluster, it's version 2. In the second line, you see name. This is the name of our chart. And in the third line, you see description about this chart. You can add everything in this description. There is another item called type. There are two types of charts. One is application and another one is library. Here, most of the Helm charts are application and the default type also is application. In continue, you see version and application version. The version, it's about the version of the chart itself, but the application version, it's the version of your application. For example, you have an application with a specific version, and after a while you publish a new version. The app version, it's the version of your application, but the version that you see here, it's 0.1.0, it's the version of the chart only. For example, you have a chart with some manifest, so you deploy it and you're using, and after a while, if you make a big change in whole of your chart, for example, add config map, add persistent volume, and so on, the version of chart will be changed. I hope you make sense the difference between version and app version. Okay, let's exit of this file and get a tree of the content again. So at the moment we know about the charts. Also, you see a template folder. Helm uses these template files which are rendered using from the value.yaml. All the manifests that we have created to run on Kubernetes cluster located in templates, and we will focus on them in next minutes. Also, there is a file called values.yaml. Let's open it. Is a file that we define all the variables related to the manifest, and we can call this file as the brain of org chart. Let's quit from here and clean the screen and see what we have to do. Okay, so we have created our chart. cd test login application. Let's go inside templates. Here are the default manifests that are located here. Let's remove all the content here and replace them with our manifest. So let's remove all of them. We don't have anything here. Let's back from here. cd this folder. My project manifests are here. Let's copy all of them to test login application and in templates. So my basic chart is ready. Let's install this chart on my Kubernetes cluster. How we can install Helm chart? Just type Helm, install, give it a name. Here it's called release name, and then chart name. For example, Helm install login application and the chart name, test login application. This name is important, but at the moment leave it as is. Just we have selected a name and we will discuss about it later. Let's back to terminal, exit from here, clean screen, type Helm, install login application. This is selected name and chart name dot slash chart name test dash login application. Enter. You see, this is your release name. Last deployed is today. In which namespace? Default namespace. Because in our manifest we didn't define any namespace, and it show us the status is deployed with the revision 1. So let's check if the application deployed on Kubernetes cluster with kubectl get pods. Here you are. This is the pods that are deployed, and just get deployment. This is the deployment name, and get svc, the service name. It uses node port. If I type kubectl get node, this is the IP address of the node. Copy this address, put it here, double points. What is the port? 31000. Here you are, the application deployed. So for remove the application, just type Helm on install release name. Done. If I go and get kubectl get services, everything down. You see, just with one command, I could install my application that here include a deployment, a service, and a secret just with one command. And also just with one command, I could remove it from Kubernetes cluster. Until now, we learned how to install and uninstall a chart on Kubernetes cluster. Let's install it again. So as you see here, it installed again with revision number 1. Let's verify deployment. Yes, it has been installed. Here, assume I want to use the application as another release. So, for example, as login app2. Click enter. Oops, it seems something is wrong. We got error. Why? Because Kubernetes wants to bring up another deployment, another service, and another secret with same names: kubectl get svc. At the moment, we have this service with this name. If I want to bring up them again, Kubernetes cluster want to bring up another deployment, another service, another secret with same names. And as they are exist like this one, it show us creating new deployment or new service with the same name is not possible, because the name that was defined in manifest are static. As you see here, we selected login DEP as a name for deployment. So if we run this manifest another time, it wants to create another deployment with the same name. So it is impossible. So what we can do? Is there a way to assign its name dynamically? How we can fix this issue? For solving this issue, we can change the name to be dynamically. For this one, we can use like that: two open curly brackets and a space, two close curly bracket. And inside this brackets, we can use variable. Which variables we can use here? One of the way to fix this one, we can use the name of the release here. Let's exit from here, save it. If you look here, this is the release name. If you remember, I have already told you this release name is important. So we can use the release name there. How we can use? Just back to manifest, and inside the brackets, using dot release with the capital dot name, like this one. After name one space, before dot one space. This is very important. This is like Jinja template. So dot release dot name give us this possibility to make the dynamically. And also we can add this one between the variable and the name. Let's save it and exit. So before we install it again, we can do it on fly and see if the variable works or not. How? Just use the same command, but at the end we can add dash dash debug dash dash dry dash run and just enter. Look here, this is deployment. The name change, login application dash login dep. The login application is this release name. So far, so good. Let's fix this issue in all manifest. Double curly bracket, space, dot, release, dot, name, space, double close curly bracket, and dash. Save it. And also for secret, dot, release, dot, name. Save it. Here we can do two things. At first, uninstall the application and install it again with new names, or update the release. Let's clean a screen. Let's update it in a state of uninstall and install it again. Let's upgrade it by Helm and replace install with upgrade and remove the debug command. Here you see another issue occurred. You see the node port. Let's going inside service manifest. If we look here, we did define a static port for node port. We can disable this one and it will go automatically. It will get random ports. Let's save it and run the upgrade command again. You see release has been upgraded. Let's check kubectl get deployment. Look here, the name change with the new name, and if I do for pods, the same for pods. Check service, also for the service, the release name added at the first of service name. Here you see random port added here. Now if I run the install with the new release and enter, new release with this name has been created. kubectl get deploy. Look here, new deployment has been created. For the service, new service with new port created here. Let's check the node, get node-oy, and let's grab this address and check on browser. Let's grab the port, this port, it works, and check with another port. With this port also works. At the moment, we have two applications running in same time with different release name. So far, so good. So let's going more deeper. Let's uninstall the second one. Done. It's removed. Just we have Helm list. With Helm list, we can see the releases name. At the moment, the first one, login app, is in the service. Here you see revision 3. If you remember, the first time we have installed the application, the revision was number 1. If you remember, for the first time we upgraded and got issue on the node port, the revision number 2 has been created. So after we fixed the port and re-upgraded that again, new revision has been created. Let's use Helm history -help. If you see here, we can use Helm history release name. So let's use Helm list, grab the name, history release name. If see here, the first time install complete, the second time, as I told you, upgraded failed because the port also it is written here, and for the third time upgraded complete. So at the moment we have 3 revision. Maybe you don't like this change and you want to back the revision 1. It's easy. Just with Helm rollback, we can back to each revision that we want. If I add -help with this command Helm rollback release name and the selected revision, we can back to that revision. Let's clean the screen. kubectl get svc services. You see the service name is like this and you don't like that, you want to back to the first release. Again, Helm history release name, you want to back to release number 1. So Helm rollback release name, which revision? Revision number 1. Enter. Rollback was a success. If I get kubectl get svc, the name change. Look here, back to the old name. But if I check history again, look here, has created a new revision. The revision 4 is look like revision number 1 because it wants to track all the changes. For that reason, it creates a new revision, and in the description you see rollback to revision 1. Again, we can do Helm upgrade, release name. Sorry, I forgot to add the chart name. Check history. Revision 5 has been created, and Helm list revision number 5 and kubectl get svc, you see, back to the dynamic name. Now, if we want control spec section of manifest in a central location, let's open this, for example, service manifest. For example, here, I want to change it to cluster IP. I want to change it to load balancer. I don't want every time I come to the manifest, I want to have a central location and do all changes there. Or let's back to deployment. I wanted to change the image. I want to change new version, for example, version 2. I want to change the labels. I don't want directly, instead of going directly inside manifest and edit them, I like to doing it in central location. Here is the values.yaml comes to play its role. Let's exit from here. Let's ls test-login. You see there is a file, it's called values.yaml. This is the brain of chart. This is like a variables file. We can define all the variables here. How we can do it? Let's open the services, for example. I want to change the type of service. Let's remove this one. Like the name that we use, double bracket, the same we do here. Double open curly bracket, space, and double close. Here we type dot values, but with the capital. Here, look, here we use the capital for the release. Also here we use the capital. Values dot. So what we have to add after these values? Leave it as is. Let's save it and exit. Open the values. If you see here, when we created this chart, automatically it has these variables here. We can remove them and use another variables that we want, and also we can use the same variable. So here we have service type cluster IP. So we can change it at first to node port. Let's grab this one, service. So we have to address this one in the manifest. Let's save and exit. Back to service. Here type service. It goes to the values.yaml file, service section dot type. Let's exit from here and test it on fly. If everything works well, we can upgrade or release. So let's, using the install command, Helm install, every name you want, or you can use the same name, dot slash test dash dash debug dash run dash dry dash run. Let's look into the service. Here is the service. Going to the type, you see added node port. If back to the values file and change it, for example, to cluster IP, let's save it and rerun on debug mode. Look here, change to cluster IP. Let's fix it on node port and upgrade it with this change. Revision 6 has been deployed. Let's clean the screen and make another change in values. For example, I want to use image variable. Let's bring the image name to here. Grab the image name in the values file. Let's paste it here. Back to manifest. Remove this one. Open bracket, close bracket. Type dot values dot image dot repository. Save it. Let's check on fly. You see the variable rendered here. Until now, we have learned how to install a chart, how to uninstall a chart, upgrade and roll back the chart to the selected revision, and learn how to play with the values.yaml. Let's consider another subject that calls Helm lint. Helm lint used to validate our Helm chart, and it will detect errors before deploying our chart to Kubernetes cluster. For example, let's open one of the manifests, vim test-login-app templates and service, for example. Let's remove dot from here. Let's save and exit. So let's install it. Helm install test app and the chart name. You see here, it shows us there is issue on the chart and cannot deploy it. So it is better before installing it, we check the errors. If there is an error, we have to fix it. How we can check the chart and see if there is error or issue on that? Just type Helm lint and the name of the chart. Enter. Here, this command runs a series of tests to verify that the chart is well formed. If the linter encounters things that will cause the chart to fail in installation, it will emit error message. You see here, error. Where is the error? In template service YAML, line 16, function values not defined. So if I back to service manifest, this is line 16, and I see there is no dot here. So if I add a dot here, save and exit, and linting again, one chart linted, 0 chart fail. If we compare it with the last time we did linted, here it showed there was an error, but now here it was successful. If you want to have more information about linting, you can refer to the official website of Helm and you can see all information about lint. Let's start with Helm repositories. And what are they? If we back to some minutes ago, here you see if we wanted to install a package on CentOS machine by YARN, we had to add the repository for that specific package. As I mentioned there, for installing, for example, Docker CE, we had to add Docker repository on our computer. Here we have the same story in Helm. Also, if you remember from some minutes ago, after we prepared Helm package, or in other language, Helm chart, as I told you before, from here we don't use Helm package, we are using Helm chart. So after we prepared Helm chart, we have to push it in a Helm repository. Or in reverse, if we want to install a chart on Kubernetes cluster, we have to add the repository name on Helm. Then Helm can access to that specific repository and pull the chart, then install in Kubernetes cluster. So what is Helm repository? A Helm repository is the place where charts can be collected and shared. Like Docker Hub, there is a Helm repository hub. It's called Artifact Hub, and you can access it through https artifacthub.io. This Artifact Hub has access to Helm charts from dozens of different repositories like Bitnami, like TrueChart, and so on. Instead of access to different repository one by one and add their repo name in your Helm, you can access to Artifact Hub, and through that you can access to all of the charts that are recorded on these repositories. So how we can access to Artifact Hub and also have access to charts? So let's see how we can access to Artifact Hub. This is Artifact Hub, and you can search for every chart you want. For example, you want to install WordPress on your Kubernetes cluster. Just you can search WordPress, and here you will see different chart of WordPress. For example, the first one is published by Bitnami repository. The second one was published by Groundhog2k. The next one is from TrueChart, and so on. Based on the ranking, we can select which one is good, and we can pull it on our machine and deploy it on Kubernetes cluster. Let's see another example. For example, you want to install Jenkins on your Kubernetes cluster. Again, you see different charts from different repository provider. If you see the first one, it has high rank in compare of the others, and it is published by Jenkins SCI repository. As you saw here, we can use this prepared chart and install on our Kubernetes cluster. As I told you, this is like Docker Hub. On Docker Hub, we can pull every image we want and use it. And also here, we can pull every chart we want. Also, we can publish our chart to this hub and share it with others. Also, we can use private repository to keep our chart on them and share it between workmates in our company. Let's back to presentation. With this command, Helm Search Hub, we can search on Artifact Hub for a chart that we want. Also, with Helm Search Repo, we can search the specific repositories that we have already added to our local machine by Helm Repo Add. So let's go to the terminal and play with these commands. In the terminal, just type Helm Repo List. With Helm Repo List, it shows us which repository added to our machine. At the moment, only I have this repository, GitLab, on my computer. But if this is the first time you run this command, you don't see any repository in your Helm machine. So let's clean the screen and check Helm Search Hub. As I told you, Helm Search Hub automatically will go to Artifact Hub and will search for a chart. For example, I'm looking for Jenkins. Enter. You see it went and search Artifact repo and find different version of Jenkins. If you see here after the Helm, there is a repository name. For example, the first one, as also I showed you before on Artifact Hub website, is Jenkins SCI. Also, we can pipe it by grab Jenkins SCI. So we can pull this chart and deploy it on our Kubernetes cluster. Let's clean the screen. Let's see how we can add a specific repository in our machine. With Helm Repo Add, we can add a repository to our Helm machine. Here, this is a complete command. Helm Repo Add name. We can select a name for it and also add the URL of that repository. For example, I want to add Bitnami repository to this machine. In Google, just type add Bitnami Helm repo, and from the result, select the second one, Bitnami Helm Charts, and you see with the first command, let's grab it and back to terminal and paste it here. Helm Repo Add. Here it's the name. We can select every name we want. For example, we can change it to Bitnami repo and the URL of the Bitnami charts repository. Let's enter. You see here, Bitnami repo has been added to your repository. With Helm Repo List, we can list the repository's name that we did add to our Helm machine. Also, I told you some seconds ago, with Helm Search Repo, we can search on that specific repository. For example, here, so let's add -h at the end of this command to show us the help. With Helm Search Repo, keyword. What is keyword? Keyword, it's the chart that we are looking. For example, I'm looking for Kafka. See, it went and searched both repositories that already I have here, but it find only in Bitnami, this version, Apache Kafka. So at the moment, you know information about repositories. This is the chart that we already use it during this presentation, and I want to share it with the other workmate. So I need to push it on a repository. Here I want to push it on GitLab repository. Let's go into internet. In Google, if I type push Helm chart to GitLab, from the result, click on the first one. Here will show you how to push your chart to the GitLab registry. As you see here, publish Helm packages in your project package registry. Then install the package whenever you need to use them as a dependency. So for publish or Helm chart, here there is a requirement. Create your own Helm chart. So we have it. We prepare this Helm chart and use it also in Kubernetes. So package a Helm chart into a chart archive. I will show you how to do it. So we can click on this one. There is instruction here, and I will speak about it in next some minutes. Let's back. Also, for authenticate to the Helm repository, you need a token. Okay, so before pushing our chart to GitLab, we need to package it. Look here, we have to put our chart in a box and seal it, then push it in repository. How we can do it? Just with this command, helm package. Back here, helm package test dash login dash app. I want to package this chart. Just enter successfully package chart, the chart package, and seal it in a box, and also save it here. Let's ls-latr test dash login dash app with this version 0.1.0. Do you know these numbers come from where? If I go to the chart and open chart YAML, look here, version 0.1.0. We spoke about it some minutes before. If you don't remember that, you can back to some minutes ago and refresh your mind again with this discussion. So let's clean the screen, exit from this folder, and this is the package we prepared to push it on GitLab repository. Let's back to documentation on GitLab with this command, curl dash request post. This is an API command. We want to post this package to where? To our GitLab repository. This is my GitLab account. I wanted to use this repository and publish the Helm chart here. Let's have a look to the command again. Here we have to add our chart name. Here it's our username and our token. And also this is the path for our project, for our repository. Just here we have to add project ID and also select a channel name. For the project ID, we can grab it from here, and also we add our username and token here. So let's clean the screen. This is the command that I replaced my username and token and also added project name and channel name here, and just enter. You see this message 200.01 created. Let's back to GitLab repository, and from the left, deploy package registry. Look here, test login application Helm manually published. So far, so good. If going down, you see there is a command Helm repo add. As you remember, this is for add a repository to your Helm. But here uses username and password to have authorization to your repository. So let's back to terminal and paste the command here. Just enter. Here you see login-app project has been added to your repository because we selected this name as a repository, Helm repo list. You see it is added here. If we want to remove a repository from the list, just type Helm repo --help. Here you see the list of command. So with remove, we can remove one or more chart repository. Let's clean the screen. So remove login app project. You see remove Helm repo list, and you see it is disappear. Let's also remove this one. Helm repo, remove this one. It has been removed. Helm repo list. See, only we have the default one that I have already added before. So let's again add our repository. Copy. Just I want to change it here with new name, GitLab repo project. Enter Helm repo list. If we type Helm search repo, it will go and search these repositories. Look here. The first one is located in our private repository. The others located in this one. Let's continue on this page and see how we can pull or install this package on our computer. As we know, with Helm install, with a release name, we can install it. So let's go into terminal. Just type Helm repo list with Helm install. For example, test login app. This is the release name, and add the repository name that we have here and the name of the chart. Just enter. It is deployed on Kubernetes cluster. If I use kubectl get svc, look here, it was deployed with this new name. If we want to uninstall it, Helm uninstall a release name. Just enter and it's gone. Let's verify that Helm list, just the first one that we have deployed at the beginning of this session. Also, let's uninstall this one, Helm uninstall this one, and also this one is gone. Let's assume one of the workmates want to pull this chart on his computer and make a change and deploy it on Kubernetes cluster. Let's create a folder with, for example, test app and switch inside that. Let's at first type Helm repo list. For pulling this chart, just type Helm pull repository name / and the chart name. Enter. Done. Here you are. This is the chart. Just at first we have to unzip it and make our change and deploy to Kubernetes cluster. If we want to unpack it during the pull process, we can add -- untar at the end of command. For example, Helm pull repository name / chart name -- untar. Enter. ls, here you are. Instead of at first pull and then unpack it, we can do both of them with one command. Just add -- untar. cd test -login and ls. So far, so good. So with this way, you can pull every chart you want. For example, you want to pull WordPress chart. Just type Helm search hub, as I told you before, WordPress. As you see in the result, the end of URLs is not completed and you see only 3 dots. So for installation these charts, you need the full URL. So it is better to browse requested chart on Artifact Hub website. Let's do it on browser. Just type in search packages WordPress. From the list, as you see it the package from Bitnami repository has better rank. So just click on Helm Chart. Here from the right, click on Install. Here there are two commands. You can use them to add this repository to your Helm machine, and also the second one is a command for install this chart. Let's copy the first one back to terminal, clean the screen, paste it here. So Bitnami has been added to your repository. So let's verify that. Helm repo list, Bitnami repository added here. So let's grab the next command and back to terminal. You see here, it's easy for you now to analyze this command, Helm install. It will going to install a chart on Kubernetes cluster. My WordPress is the release name. Bitnami, it's the repo name, and WordPress is the chart name. Also, -- version and version number. This is the version that we want to install. Just enter and it will go and install WordPress on your Kubernetes cluster. You see here in namespace default, status deployed, revision number 1. Here the chart name is WordPress. Here there are some description how to access WordPress by its URL. So let's type Helm list. Here you see my WordPress at the moment is running on your Kubernetes cluster. So let's uninstall it because we don't need it anymore, and also verify it by Helm list. So today with this presentation, we learn about Helm, what is charts, how we can create a chart, how we can deploy a chart on Kubernetes cluster, and also we learn what is repository, how we can publish our chart to a repository and share it with a workmate, and also how we can pull it from the repository. I think this is enough for a beginner to learn about Helm. If you find this presentation is useful for you, I will appreciate to like it and add your feedback in the comment section. Thank you so much. See you in another videos.